Hey folks, welcome back. In this video we're going to go over two worked examples to show you how to do problems on projectile motion involving objects that have been launched vertically upwards. Now if you haven't already done so, check out my previous video covering the theory on this topic, and that way you can apply what you learned in that video to this one. So let's get started. Question 1 says that a construction worker living on the edge throws a hammer vertically upwards to his colleague standing on scaffolding. The hammer is launched with an initial velocity of 9 meters per second and is caught when it reaches its maximum height. Determine the height of the hammer when it is caught. Well, just like we did for objects dropped from rest, because we're only dealing with the vertical motion of the projectile here, we can ignore any horizontal motion, and we're going to use suvat just like we do for any projectile motion question. So writing down vertical first of all to show it's the vertical motion we're dealing with, we can then write down suvat. So first of all, we want to find what the displacement s is, the height of the hammer when it's caught. We know that the initial velocity of the hammer is 9 meters per second. The final velocity is 0 meters per second at its maximum height, so that's something we need to be aware of here. The acceleration is going to be minus 9.8 meters per second squared if we assume upwards is positive and downwards is negative. And lastly, our time is unknown. So I'm going to put a star next to s here because that's the one we're trying to find, and therefore we want to choose an equation of motion which does not have t in it. We can therefore use the equation v squared equals u squared plus 2es, and substituting in our numbers, we get 0 squared equals 9 squared plus 2 times minus 9.8 times s, and if we do our 2 times minus 9.8 we get minus 19.6, and that means we have minus 19.6 s, so if we add that over to the other side, we get 19.6 s equals 81, and that 81 comes from the 9 squared there, and dividing both sides now by 19.6, we get s equals 4.1 meters. Question 2 says before a kickoff at a football match, the referee tosses a coin vertically upwards into the air with a velocity of 5.5 meters per second. Assuming the referee keeps their hand at the same height at which the coin left it, how long would it take for the coin to return to their hand? Well, just like in question 1, we're only dealing with vertical motion here, so we're going to use suvat here, and we're actually going to analyse the first half of the coin's motion up until its highest point, because if we do that, then we can write down that the final velocity of the coin is going to be 0 meters per second at its highest point. And then we can use the idea that the second half of the coin's motion is going to be identical to the first half of the coin's motion. So we don't know what the displacement s is here. We know that the initial velocity is 5.5 meters per second, the final velocity is going to be 0 meters per second at the highest point, the acceleration is going to be minus 9.8 meters per second squared, again assuming upwards to be positive and downwards to be negative, and lastly the time is unknown. So putting a star next to the time because that's the one we're trying to find, we want to use an equation of motion here which does not have s in it. So we can use the equation v equals u plus at, and so substituting in the numbers, we get 0 equals 5.5 plus minus 9.8 times t, and now adding the 9.8t over to the other side, we get 9.8t equals 5.5, and now dividing both sides by 9.8, we get t equals 0.56 seconds. Now remember, this is just the time for the first half of the coin's motion, but it says in the question that the coin is going to return to the hand which has been kept at the same height that it was to begin with. So we can say that this is the time to reach maximum height, but the coin will take the same time to travel upwards as it does downwards. So you might be thinking that we can find the total time of flight by just timesing by 2. So the total time of flight is equal to 2 times the 0.56 seconds, which equals 1.1 seconds. That's all for this video folks, thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video one of these and subscribe, and I'll see you in the next one. Take care.